All right, well, welcome to lesson 13, and we are going to be classifying triangles today. And we are going to be classifying triangles by side length and by angle measure, or we can combine them and do both. So we're going to be analyzing and classifying triangles today. And so the first thing I need you to do is in your student learn book, this is page 101, but the 3 pages before this, page 95, 97, and 99, there are triangles, which I have already gone ahead and cut out. And I would like for you to go ahead, pause this video, and go ahead and cut these triangles out because we're going to be using there are 6 triangles, we're going to be using all 6 triangles today to analyze, which means to study and to look at their attributes, and then classifying, like sorting. So go ahead, pause this video, cut these out, and then make sure you have the other thing you're going to need, is your right angle template. And if you lost yours, maybe like I did, I'm going to make a new one. I'm just going to simply fold a piece of paper once, and then make sure the other side is lined up. These little sides here. And then I'm going to go ahead and mark this because this is my right angle. Which is 90 degrees. So go ahead and pause this video and then come back when you're ready. Okay, well, I'm assuming that you have gone ahead, gotten all your materials ready, and we're gonna take these triangles one by one and go ahead, and I'm just gonna lay them out here so I can see all 6 at once, and I'll put them in order. Z, E, and then letter F right here. Okay, so I have all 6 triangles laid out, but we're going to really work one at a time here. And since we just got done looking at various angles, I thought we would stay there. And then we've also done symmetry. So we're gonna go from angles, which we did last week, and symmetry, which we did yesterday, and then we're going to talk about the third characteristic or attribute that we're going to look at. So the first thing we're going to do is talk about the angles, and that's why we need our right angle template. And I'm going to go ahead and measure or compare each of these angles. So if I were to match up, you can see that the whole angle is hidden behind it. In fact, it might be easier if I put it right on top. Get the vertex lined up there. And I can clearly see that it is less than 90 degrees. And if you remember, anything less than 90 degrees is acute. So I'm going to go ahead and mark that with a letter A to say, oh, I know that one's an acute angle. And they do have letters on here already, but they are just so that we can specify angle X or angle Z or angle Y. But I'm marking them with what they measure. So this measures as an acute angle. And I'm going to go ahead and do that with all 3 angles. So again, I get one ray lined up, or one side with the vertex is lined up, and I can clearly see this is also less than 90. And if I spin this around and do the next one, I can also see that this angle is also less than 90. So I'm going to go ahead and mark with an arc and say that all 3 of these angles are acute. Okay, so that's the first step, and we're going to do that with each of our triangles here. So again, I can clearly see, yep, that one is definitely an acute angle. mark that and say that's an acute angle. And get the next one here. Yep, I can clearly see this one is also an acute angle. And the third angle is also acute. So all three of these are also acute. So I'm just setting these aside, and we're going to come back to look at those a little bit later. So I'm on to triangle letter C, and clearly that's an acute angle right there. So that one is. So I'll go ahead and mark that as an acute. Let's see, this one, nice and skinny, like a cute little animal as we talked about. That is definitely an acute angle, so I can mark that as an acute. And then we have this angle right here. And if I line that up, oh boy, notice what I see. This ray right here is more than 90 degrees. In fact, if I did it this way, this side is lined up, but this side, it's not right, it's not less than, it is more than. So I know this is an obtuse angle. So I'm going to mark this as the letter O, or obtuse. I'm just using the first letter of the angle name. So letter C, we have that clearly marked, all three angles. Come to my letter D triangle, and I see that this angle is acute. Turn it. I see that this angle is also acute. And I turn it. Ooh, this one matches up perfectly. Look at that. The right angle template matches perfectly right in that vertex. Excellent. So I'm going to mark this one with that square corner, and we know this one is a right angle, so I'm going to mark it as a right angle, and that has that special marking to indicate that it's a right angle. All right, that one's done. Triangle E. Triangle E. Clearly this one is acute. This one is acute as well. And this bottom angle right here, ooh, that's another one that matches up perfectly. And if I did it front or back, it matches up. So again, I'm going to put that special symbol, that square corner, and mark it with the letter R. So that is a right angle. All right, we've got one last triangle to go. We have letter F, triangle F. And put the vertex right there. Oh, I see that definitely not 90, not more than 90, so it's less than, which makes it an acute. This angle right here, match up to one side, and ooh, I can see that this would be we're 90 degrees in, and this is more than, so I can mark this as obtuse with an O, and hopefully by now you can recognize that this one is also an acute. So, and just to confirm, I will place it on my template here. So I have all the angles marked in my triangles. The next thing we want to do is, based on our lesson yesterday with symmetry, and we're going to go through and talk about symmetry with each of these. So I'm going to set those aside, pull out triangle A again, and symmetry is if I can get one half to match the other. And so I'm going to see if I can get them to match. And this one definitely looks like the left side matches the right side. So I'm going to go ahead and I'm just going to put a dotted line right down the middle here to indicate that that is a line of symmetry. But is that the only line of symmetry? Can I fold it a different way and also get that line of symmetry? So I'm going to try since I went from a vertex to the middle of a side, I'm going to try a different vertex to the middle of a side and see if that works. And what do you know? It does. From that vertex to the middle of the side. So the two sides, these sides match up. So think about, if they match up, that means they're also the same length. And we're going to talk about that in a minute. So these are the same length. But we are right now looking at this line of symmetry. So I have two lines of symmetry so far. I wonder if I could get it to match up from this other vertex to the middle of this side. Let's try that. And depending on how good your folding skills are, I know sometimes students really struggle with folding. And I'm not the perfect, but I'm going to go ahead and say that this is a line of symmetry. If I can finagle this just a little bit more. That's better. There we go. So now I have that line of symmetry again. So I have three lines of symmetry on this triangle. All right, so that one is done. In fact, I'm going to go ahead and mark this as 3 lines of symmetry. All right, that's triangle A. And I don't have to do these in any particular order, so just happen to pull out triangle D next. And let's see, if I were to take this vertex right here, where that right angle is, and I can clearly see that these two sides are not meeting up, so they do not match. How about this way? Well, clearly, turn it around, going from this acute angle, I can see that, yeah, this is nowhere near the same length as that one, so that one's not going to work. How about this one? These are pretty close, but again, if I were to fold that, I can see I've got a little overlap here, so that's not going to work. So this triangle D has no lines of symmetry. No lines of symmetry on that one. Okay, let's move on. Let's go to letter F. Triangle F here. It looks like if I fold it this way, that these match front and back. So that would be a line of symmetry right here. And if I did it this way, I can see that, nope, not going to match because this side ends right here, and I've got all this extra length on that side, so that's not going to work. And the same thing happens when I try this way. So this triangle has one line of symmetry. 3 down, 3 to go. Letter B. And looks like I can get one right down the middle this way. Front side looks good, back side looks good. No overlap, so this would be a line of symmetry. All right. These two sides don't match up, so that's not going to be a line of symmetry. And same thing on this side. If I went this way, they're not going to match up. So this only has one line of symmetry. And hopefully you're following along with your own triangles and making the same marks that I am. Oh, this one. Oh, this is a weird looking triangle. And right now I can clearly see that if I were to go from this vertex to that obtuse angle right there, that, yeah, they don't match up. They are not the same size. If I went from this acute angle on my right here, you can clearly see those sides don't match up. And if I went from this acute angle on my left, that those sides don't match up. So again, this triangle has no lines of symmetry. And we'll set that one aside. All right, on to the next one, last one here. All right, this is triangle E, and if I were to go by this acute angle on my right, that does not match, so that's not going to work. If I went from the acute angle on the top, that's not going to match. I've got this overlap here. How about from the right angle? Would this match? Ooh, that looks like it will. So one side matches the other. It is a mirror image. And when I open that up, you can see that, yes, this is a line of symmetry. All right. So we've got our angles marked. We've got our lines of symmetry marked. And the last thing we want to talk about is the length of the sides. Now, hopefully when we're looking at triangle A, you notice that these two sides, this side and this side, matched up perfectly. And so that means they're equal. And if I went around, all the sides actually match. So this has not only one or two lines that match up, it has all three. And we're going to go ahead and mark that in a special way. So I'm going to get out a different color marker here. And we're going to put a mark on that side. And I'm going to just get a little paper so I don't mark on my counter here. So I'm going to place one mark. I'm going to place one mark on this side. And I'm going to place one mark on this side. So because they are the same mark, I'm saying that they are the same length. So triangle A, it has three acute angles, it has three lines of symmetry, and it has three equal sides. So we're going to come back to that in a minute. Looking at triangle B, we had one line of symmetry, so I know that the two sides, these two sides are the same. This one down here is different, so I'm going to mark again. I'm going to mark the ones that are equal with one mark, but I'm going to use a different color. Not only a different color, but I'm going to place two marks down here to indicate that these two sides are the same. This one is different. So that one is marked. Letter F, triangle F here. Again, folding that on that line of symmetry. These two lines match up. This is the same line, and that's really long. So again, I'm going to mark this. This side matches this length. And because this one is really long, it's a different length. I'm going to put 3 marks. I could have, well, maybe I should have used 2 marks. Anyway, 2 marks. These are the same color, and the same number of marks indicate that they are the same length. This one is different. So, all right. Let's go here. This had no lines of symmetry, and I noticed that all 3 lines happen to be different. So I can mark 1 with 1 line. I can mark a second with 2 lines, and I'm going to mark a third side with 3 marks. So that indicates that all 3 sides are different lengths. And again, that's going to become really important. All right, again, we have no lines of symmetry here, letter D. So that means none of the sides matched up, no matter how I did it. So we can go ahead and mark kind of the same way. 1 mark there, 2 marks here, and 3 marks here. And I notice I put them on the side because that's what we're talking about, the length of the side. And they are all different. And if I were to use a ruler, I happen to have a ruler right here. If I were to measure, I can see that that is 15 centimeters. If I measure this side, that's 11 centimeters. And this side, well, it's 15 to here, and it's still longer than that. So I know it's a lot. So I know that we had 11, 15, and one that's longer. So again, they are all different lengths. And finally, letter E. We had 1 line of symmetry. So I know that these 2 sides match up. And this side right here is different. So I'm going to mark this side matches this side. And when I do that, I also want you to pay attention where I'm marking. The line of symmetry here, it's actually between the 2 sides that match up. And this side is different. So we've got all of our triangles marked now. Again, notice that here's my line of symmetry. The 2 sides on either side of that line of symmetry, the ones that are equal. Same thing happened with this triangle here. Here's a line of symmetry right down the middle. The 2 sides on either side of that line of symmetry are equal. Same thing with this triangle. Line of symmetry, the 2 sides on either side of it are equal. And when we get to letter A, we'll zoom in so we can get a better picture of this one. Again, line of symmetry going right down the middle. 2 sides on either side of it are equal. If I turn it, here's our line of symmetry, and here's the 2 sides that are equal. Now we just said that this side was equal to this side. Now we're saying this side is equal to this side. So by reasoning, I could say, well, if this side is equal, if side A is equal to side B and side B is equal to side C, then A is also equal to C. And I can turn that and I can clearly see that. Here's our line of symmetry, and here are the 2 sides that are equal on either side of that line of symmetry. And these guys didn't have any lines of symmetry. So we're back to square one with those. All right. So now we're going to start getting into, we've done the analyze, we're going to start getting into that sorting or classifying. And I'm going to start by using our angles. We have acute, and we talked about they are less than 90 degrees, and we're looking for all acute angles on the triangle. The next would be right, and we know that a right angle is exactly 90 degrees, and so we really have one right angle. And the third classification would be obtuse. So I'm going to go ahead and spread those out. So we're going to take our triangles now, and we're going to take a look at one at a time here. And this one I happen to see, well, there's an acute angle here, acute angle here, and an acute angle here. And doesn't have any right, it doesn't have any obtuse. All three are acute angles. So that would be going in that classification up there. And we're going to come back to that. If I came to this one, I have an acute angle here, an acute angle here, but right here I have that obtuse. Well, right here we have one obtuse angle, so this one comes down here. Triangle B, we have an acute, 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 all acute angles, so that would be up there. Triangle F, we have acute, 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 and obtuse. This one's got an obtuse angle too, so this one's going to come down here with it has one obtuse angle. Triangle E, I can clearly see this one. I've got it marked with a right angle. It's got an acute and it's got an acute, but it does not have all acute angles. It has a right angle. So this one actually is going to go with a right angle. And then letter D, triangle D, again, I have an acute angle, and a right angle. So that is also going to go with right angles. So I have just sorted or classified the triangles by their angles. These two triangles up here are acute, these two are right, and these two are obtuse. And I can tell that just by looking at their angles. All right, well that's one way, and we talked about we're going to do it two different ways. So I'm going to pick these up, and we're going to look at our next set of criteria. And the first set of criteria is equilateral. And I have three equal sides, and if you can almost see the word equal, excuse me, in the word equilateral. And lateral is a Latin word, I believe, excuse me again, for side. So equal sides, three equal sides. What if we had two equal sides? That would be isosceles. So we have three equal sides, we have two equal sides, and this is a kind of a hard to say and hard to spell. It's isosceles, and that is basically two equal sides. And then we will have some triangles that have no equal sides, and they're called scalene. So we can look at the number of sides that are equal. If I just happen to pull this triangle B, and again we marked them, it has these sides are equal. This one's different, so how many sides does it have that are equal? Hopefully you said it has two. So I'm going to place this one right here. It has two equal sides. That would be an isosceles. Here's that triangle A. I have marked all three sides with one mark. They are the same, so that would be three equal sides that are so equilateral. Letter F, I have two marks that are the same and one that's different, so two equal sides. That would be isosceles. And I'm going to come to this one. This one was triangle E. Again, I have a mark here and a mark here. They're the same, so they are equal. And this mark is different. So these are two equal sides. I'm going to put right here with isosceles. When we come to our next one, we said this side has got one mark, this side has got two marks, and this side has got three marks. So they're all different. Notice that it also says no lines of symmetry. So no equal sides. So It also has no lines of symmetry. And then our last one, letter C, again, we have 1 mark here, 2 marks here, 3 marks here to indicate that they are 3 different lengths. And isn't it interesting that the ones that have 2 or no equal sides are also the ones that have no lines of symmetry? So we have sorted our triangles by side length here and also by angles. So we are now going to take, I'm going to put these aside, and we're going to grab our book and we are going to start filling in the information here. So I'm not going to sketch the triangle right now, but I am going to look at triangle A. So I'm going to pull out triangle A here, and it says attributes. Include the side lengths and the number or angle measures. So looking at triangle A, we're going to start with a side length, because when we come over here, we're going to start by the side and then by angles. And I'm going to write those words in over here. And we said that there are 3 equal sides. And the angles, we said that there are 3 acute angles. And we're also going to include the lines of symmetry. So I'm going to go ahead and write in 3 lines of symmetry. So we have taken all the information that we have marked up this triangle with, and we've just listed it right here. And this triangle happens to be a really special triangle because it has 3 equal sides. And I'm going to go ahead and tell you that actually if I were to use a protractor and measure each of these angles, they would also be equal. And there's a reason for that, because this is a regular polygon. All the sides are the same length and all the angles are the same length. So a regular polygon has equal sides and equal lengths. I wonder if you can think of another polygon that has equal sides and equal lengths. So because it has equal sides, we call it an equilateral. And because the angles are all acute, we call this an acute. So I want you to think of these two as the first name, the middle name, and then triangle would be the last name. So the name for this triangle is equilateral acute triangle. So think of your first name, your middle name, and your last name. Equilateral acute triangle. And when we come to, let me find letter B here. Triangle B, we're going to go ahead and we're going to do the same thing. So we have 2 equal sides. We have 3 acute angles. And we have 1 line of symmetry. So because we have 2 equal sides, we know that fancy name is isosceles, which again means 2 equal sides. And all 3 angles are acute, and so it gets the same name. It has the same middle name as this previous triangle, but it's different. It has a different first name. This is equilateral acute. This is isosceles acute. So this is isosceles because it has 2 equal sides, and acute has all 3 angles are the same. All right, letter C. This one right here. Letter C, we said all 3 sides, so no equal sides. it has, ooh, this one has one obtuse angle and no lines of symmetry. Because it has no equal sides, if you remember, we called that a scalene scalene. Because it has the obtuse angle, we're going to call it obtuse. And think about that. The angle names are how we measure them, whether they're acute, obtuse, or the third one is going to be right. So this is a scalene obtuse triangle. Letter D, we have no equal sides. We have one right angle. One right angle and no lines of symmetry. Because we have no equal sides, it's a scalene. Because we have a right angle, it's a right. So it would be a scalene right triangle. Scalene right triangle. Letter E, we have two equal sides. Two equal sides. We have that one right angle. And we have one line of symmetry. So, two equal sides, think about this. Two equal sides up here. Oh, that was isosceles. And because it's got the right angle, it's a right. So isosceles right triangle. And the last one, letter F. We have two equal sides. We have that obtuse angle right there. So we have one obtuse angle. And we have one line of symmetry. So because we have two equal sides, it's isosceles. Because we have the obtuse angle, it is obtuse. And now we have our fancy name for this one, isosceles obtuse triangle. So we have not only analyzed and looked at the different attributes of the triangles, we have classified them as well. We have classified them by sides and by angles. And there was a template, or some vocabulary cards, and so there's 2 pages. If you happen to are able to print them, you can print these off. These are much bigger than the previous ones. I think I have, this was the one from yesterday, line of symmetry. You can tell that they're way bigger. But these are good to study with. The other thing I would encourage you to do, I'm going to go ahead and just take a piece of paper here. Notice that I have split it down the middle. And if I went by sides and by angles, I could make myself a chart and list the names of each of them. So by sides, equilateral, isosceles, and scalene. And if I did by angles, I do acute, right, and obtuse. And I could include a picture and a definition as well. That's something that I would encourage you to do, is go ahead and fill this in. You could put this in your journal. The other thing I want to talk about is, now that we have page 101 complete, I would like for you to go ahead and you're going to work on the problem set. And you notice here that they have also included the little tick marks or dashes. So you can tell, and this one has the angle measure, you can tell whether or not the sides are equal or not. You're going to be circling, you're going to circle one in this box and one name in this box to identify this triangle. And you're going to do that for all 4 of these. I'd like you to go ahead and do numbers 2 and 3 on page 104. There is number 4. I'd like you to work on this. Notice that it says use a ruler to connect points to form 2 other triangles. And there's lots of points here, but again, use each point only once, and none of the triangles may overlap. So you do have to be a little careful here about which ones you choose. I'm going to go ahead and I'm just going to connect points here and draw in my triangle. And so I'm going to name this triangle using the vertices. So this would be triangle A, E, I. And I can probably get another triangle out of there. That would be the 3rd one. And then I'm going to go ahead and classify this by the side length and by the angle length. You can try 5 and 6. They're kind of optional if you would like. But then when you get to the exit ticket, again, I encourage you to do the exit ticket in your book first, but then you're also going to submit that online through the link. So until next time, we're going to work again with triangles some more, but that's a lot of information today, and it would be a good idea, again, to print these off, use vocabulary cards, or you can even make them yourself as I did here. Now, I didn't include the picture right now. I could go ahead and add them in later. So, all right, have a great day.